All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm. InRhythm is a modern product and technology consulting firm, and we have a lot of exciting lightning talks coming up that we have specially curated for all of you. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants they share their knowledge on the latest technology trends in the industry that will help you keep learning and growing in your career. So this week, we are going to learn about a very important tool, which is called Infracost, where you'll find out how to find cloud cost estimates for Terraform using this tool. And in especially in current economic conditions, all the enterprises are looking to cut costs. So learning infra costs is the need of the hour. And this talk is by our DevOps expert, Taufiqur Ashrafy, and we're going to play it for you next.
Okay. So for the next part of the DevOps workshop, we're going to talk about Terraform, a competitor to Pulumi, has definitely has a much larger community. It was originally built by HashiCorp, which is also a pretty big company, and it's also widely prevalent in use, especially when it comes to implementing infrastructure as code. Furthermore, we're going to talk about a tool called Infracost. We'll see how this tool actually fits into the theme of, the current economic climate here in the U.S. at least, and across the world as well, and how we can stay more cognizant of, the monetary concerns when it comes to provisioning resources. So Terraform. Let's begin by taking a look into the world of infrastructure as code as achieved using HashiCorp's popular tool, Terraform. So infrastructure as code. Um, so with infrastructure as code, we do get the same benefits of application development when provisioning infrastructure. And this concept itself um, kind of follows the whole left shifting paradigm where we can bring the whole process of provisioning infrastructure, which originally used to happen later on in the life cycle, but now we can bring it earlier as part of application development. And not only that, because this is now implemented as code, we can use everything that we do when it comes to writing code, which includes source code management and version control tools. And furthermore, we can now include, when writing infrastructure as code, we can also participate and collaborate on it with pull requests, the same way we do with application development code as well. Furthermore, we have the ability to maintain multiple cloud providers at once. As we saw in James' presentation, even with Pulumi and at Terraform, for the architecture that you want to stand up for your organization, it isn't strictly AWS that you need to use. You can also import, Azure or GCP and have a more hybrid setup as well when using infrastructure as code. And also the ability to provision a full stack entire infrastructure at once. So with infrastructure as code, you can have your entire infrastructure architecture provisioned at once and destroyed together as well. And ultimately, what this allows you to have is a separation of environments, an entire infrastructure architecture for development, an entire architecture for staging, and the same entire setup for prod as well. And it's kept consistent throughout each environment. And finally, and also we can modularize the pieces of infrastructure. So Since it's now maintained as code, I can write my own modules that comprises of multiple different sets of resources, and even submit it to like the Terraform registry. I'm sure Pulumi has one as well, and to keep it more modularized and give it the ability for reuse. And similarly, increases portability and flexibility when we do this. And finally, we have the full automation of infrastructure as well. The full automation of infrastructure, we can use CI/CD pipelines since it's now applicable with source code management tools. We do also get the capabilities of CI/CD with it as well. So here comes Terraform. And as I mentioned earlier, Terraform was originally built by HashiCorp, and it uses HCL, which is HashiCorp's configuration language. And like other configuration languages, it's human and machine friendly. Not only that, it's declarative. So the code is exactly as you see it. So it's just a matter of defining the resources, specify the settings, and that's exactly what will be provisioned. So no need to worry about logical branching or jump statements or anything like that. Everything you see is exactly as is. And each of these resources does provide outputs, and those attributes that are outputted can be then used with other resources. So for example, in this code snippet right here, we basically have the typical Elastic Beanstalk setup. And for Elastic Beanstalk, when deploying, a web application, there's two components to Elastic Beanstalk. There's the application and then the environments. So as you can see here, the exported, the output of AWS underscore Elastic underscore Beanstalk underscore application is then used in the second resource, the Elastic Beanstalk environment on the second line. So with this, I can, we can have a contiguous chain of resources that get dependent on one another and get the resource, gets the settings and, all the outputs from one resource used in another. So let's take a look at how Terraform works. There's a few simple stages for provisioning your infrastructure. And the first thing is that here on the left, if your organization, before adopting Terraform, already has resources provisioned, you can actually pull those in by running Terraform import. So that way you can get it maintained onto your state file. Once that's done, you can add more configurations to it. So add more resources that will also get added to the state file once you execute Terraform plan. Terraform plan is pretty much a dry run of showing you all the resources that are to be added, that are to be changed, or to be destroyed if they've been removed from the code. And then finally, the output of that plan, you can apply it. And applying is where the execution takes place, and it's going to render and provision all those resources to your respective provider that was defined, whether it be a cloud provider or local. And just one note that the state file that is used for all of this is typically a JSON file, kind of what we saw in James' demo for Pulumi, and it has a representation of all the resources and its state. So in the event there are multiple engineers looking to provision different resources to the same system architecture, this state file would need to be maintained centrally. And that's where we saw James talking about an S3 backend. So if this state file is maintained centrally on S3, anybody trying to update the infrastructure via code they can refer to that state file as the source of truth. All right. And that's pretty much, those are pretty much the stages to provisioning Terraform. As we saw, the code is declarative. Um, we don't have the flexibility that James kind of showed. As an application developer, writing JavaScript, writing Python feels more natural than, having to learn HashiCorp's configuration language, which is fairly simple, but it is a new language that needs to be learned. So while it doesn't have that flexibility, it is very simple to kind of, write the code for your resources, plan it, see what's to be provisioned, and apply it. So now let's look at a popular tool that was released a few years ago called Infracost. And now this tool is going to give us the insights into the cost breakdown of the plan file that we generate when running Terraform plan. And this is pretty much a game changer because, when we're collaborating on PRs for Terraform, we'll talk about the settings, if there's any adjustments we can make or any other resource we can make for, a sound architecture. But with Infracost, it's now going to add cost to the discussion. So, it's really going to bring it up front, when working with infrastructure as code with Terraform. So let's look into, why even use this at all, especially in this day and age. So we're all aware of this. Over the past year, the economy has made a significant impact on the tech industry, especially. Stock prices are looking like a falling knife, and they have fallen for many of these tech giants. And they've also, these tech companies have also begun to lay off their employees. And, with inflation, with the current economic climate, everything that's going on, cost, money, this has been like a recurring motif the past 6 months to a year or so. And even on the technology side of things, there has been trade-offs made within some of these companies like pre-render and Basecamp. Over recently in the DevOps world, there was a movement for migrating to cloud. So, there has been cloud migration taking place at many organizations to adopt, AWS, Azure, GCP. But recently, there has been a few companies doing reverse cloud migration. And because of, the rising cost of cloud services, especially AWS, some of these companies like pre-render and Basecamp especially, that are more on the mid-size in terms of company size, they've been reverting back to using on-premise solution or a hybrid solution, where they're compromising on operations and managing infrastructure for lesser cost. And ultimately, yeah.
Yeah, no, it's definitely it's kind of up in the air right now. I mean, yeah, like you're saying, there are some folks that are finding more benefit of moving away from the cloud and finding that they can save a lot more money if they are able to host their code on their own servers. The amount of money they invest into having to support actual technicians to take care of that might be cheaper than, allowing everything to run in the cloud, especially if you don't have folks that are knowledgeable enough, about the cost of some of those cloud resources it can run away really fast, because different cloud providers charge different ways, like Amazon, I think for some of the EC2 instances, you have to block it off for like a day, whereas like Azure, it's kind of like a pay-as-you-go plan. So I mean, even these different cloud providers have different cost mechanisms that they use. And yeah, depending on if you're like a small company or a big company, it might be beneficial to do some sort of hybrid thing, or utilize the cloud resources when necessary. Um, yeah, a lot of trade-offs for sure.
Yeah, definitely. No, James is right. Those are all valid points. And ultimately, having to, manage uh, whether it be like, Dell servers or something on premise, there actually has been companies providing like a white glove service type of thing where, they'll help you manage your on premise, mini data centers. And it is a solution like, Basecamp's pretty popular, but it's something that they're looking to. They haven't fully migrated off to on premise, but that hybrid solution is where people are moving towards. But yeah, it's going to be interesting to see how this ultimately plays off, later this year as well, as the economy continues to play out. So now, we've seen this. These were some of the primary reasons as to why, it's very important to make sure that we include this tool as part of our development. Infracost can basically read into your Terraform plan and provide a breakdown of the cost for the resources that you want to provision. An account is needed to obtain an API key, but there's a free tier available. So anybody can, sign up and get the API key to run this tool. Also, there's several outputs that are available to render out this information. Right now, we're seeing it in a table form here. It could also be an HTML report or JSON as well. And the best part about this is that it's available as a GitHub. So what that means is that, you can now gate commits and PRs from being acceptable if it exceeds a cost threshold. So if, this is pretty big because now that we have the capability to bring cost into this discussion, prior to applying a plan for the resources, it's going to keep cost at the forefront of everything. And, we can have those automated checks to make sure that new changes to infrastructure is rejected if it exceeds the company's budget or any specific threshold for that matter.
Yeah, and instead of like more that shifting left, like instead of finding out about it later, let's move it a little bit further left.
Yeah. And with GitHubs, definitely that's a huge one, especially during development. So yeah, I think VS Code also has a plugin as well. It has an extension that's going to, as you define the resource with the settings, it'll inline the cost right above it. So, it's a tool that's well built, super flexible, and, provides a lot of capabilities. I believe Pulumi is still in the works of having this, a feature like this implemented. So currently it's just Terraform that's support. And yeah, in the screenshot, you can easily see there's several Terraform resources here with its overall calculated cost. And you can see the overall total at the bottom right corner. We're going to use this and we'll see this in action for the workshop portion of this presentation. And here are some other just very beneficial links that I suggest everyone looks over. First, we have HashiCorp's docs on the, there's the foundations of Terraform And if you're looking to add it to your arsenal and transform, the infrastructure provisioning via code, it's highly recommended you look it over. We do have some thorough documentation on all the resources and the definition for Terraform for AWS cloud providers. So the second link is an example for that. And their documentation is pretty superior, way better than Blume's, in my opinion. Everything's up front with a bunch of examples, and it literally tells you all the inputs and the outputs that you can get for defining each resource. And then for Infracost, they also got some super useful documentation on using the tool for different scenarios, whether it be CLI or part of CI/CD as well. It also provides a dashboard to store all your calculations on the infrastructure as well, based on your API key. And finally, we have a few interesting articles for some of the companies that we mentioned, and details on why they're moving from cloud providers back to on-premise. So definitely some interesting reads there as well.
All right. That was a really awesome talk. Thanks, Taufiqur. I hope you all enjoyed it. And as a reminder to you all, we do the InRhythm Lightning Talks on Thursdays at 5:15 p.m. Eastern Time. Our next Lightning Talk will be on Swift charts, and that will be hosted on 4th of January by one of our senior iOS engineers, Rehana. Swift charts is a really powerful and concise Swift UI framework for transform your data into informative visualizations. And with Swift charts, you can build effective and customizable charts for your iOS applications with minimal code. So I'm really looking forward to this talk. Make sure you mark your calendar for January 4th. Thank you all once again for joining. Have a wonderful evening, happy holidays, and I'll see you all on Jan 4th.